Yeah, appreciate it. Thanks for the invite today. Glad I could participate. And yeah, as you mentioned, Rick, this is the class that we teach at CD events. We teach this actually all over the world. Fiber is becoming a pretty hot topic, and there's a couple of reasons for that. We'll look at that, the reasons. We'll look at the technology, some of the best practices. The webinar really goes over that information. Now, the one thing that it's hard to do in a webinar format is to actually teach you how to terminate, but the good news is the technology's evolved so quickly, so much over the last couple of years. You can literally watch a 5 to 7 minute video, learn how to terminate. That's a big part of what we do with folks. So if there's questions after the class today, feel free to reach out to your AllNet partner. Feel free to reach out to us, and we'll get you the right information to keep you moving forward. So with that, let's start rolling through the slide deck here. And this is a really popular subject. And if I look back 3 years ago when we were working on a lot of the optical engines, developing a lot of the fiber optic technology, the folks that I'd talk to when I'd travel around and visit with integrators, it was a matter of if we got into fiber. Right? Why are we talking about fiber? Will we really need to do it? There were folks that have installed fiber for decades, literally decades, and they never used it. And so I constantly got the question, are we really going to do this? If we'll really ever use fiber, is this relevant? And it's no longer the case, okay? Today, it's not a matter of if you get into fiber, it's when you get into fiber. And really, the time is now. The technology really dictates, and you'll see that today. The technology is dictating the need to move to these faster cabling networks. And fiber is, frankly, the fastest network, the cabling mechanism, the electronics mechanism to move our signals from point A to point B. It is the future of AV. Now, for folks who are looking at this and saying, hey, this is completely new to me, I don't know where to get started, here's the good news. The fiber optic ecosystem, so all the different parts and pieces that we work with, it's really not that different than the twisted pair ecosystem that we've been using, the copper-based technology that we've been using for years. So what do I mean by that? As you get going here, as we talk about the different parts of the infrastructure today, you will see bulk cable is a big part of this, right? And most of our webinar today talks about bulk cable, bulk fiber. And we'll go over the different types. We'll talk about, what are the pros and cons of the different formats and build cycles. But do know that as you get into fiber optics, you will be working with bulk fiber, bulk connectors. It's really pretty easy. And the surprising thing for most people who are new to fiber is you can actually terminate this faster than you can terminate a shielded Cat6 or Cat5 cable. You're reliably terminating in the field in under a minute. Now, patch cords are another really interesting part of the fiber infrastructure because we tend to think of patch cords and pre-made cables and kind of these short lengths, right? The cable that I'm going to use in my rack and I'm going to attach my different devices, my electronics together. In the fiber optic world, patch cords, pre-made cables, these come in some pretty crazy lengths and builds. And where most integrators actually start their fiber experience is with pre-made cables. Folks who are coming in and saying, look, I need a cable, but I want it to just show up ready to go. 600 feet, 2,000 feet, 3 miles. Really, fiber optic cables are built in any length, any configuration, and they're designed to be pulled and plugged in. Again, pre-mades are where a lot of integrators start just because it's easy, and surprisingly, they can be less expensive than bulk cable and connectors just because different technology goes into them. So this is something that you're going to want to keep in mind and definitely talk with your different AllNet partners about because, again, this is where a lot of integrators start. Now, specialty cable, right? What do I mean by that? Direct burial cables, tactical cables. So all the different things that we'd work with in the copper world, we're also seeing in fiber. If we're dealing with cable, we're dealing with wall plates and rack boxes and rack trays, pretty similar to what we've used in the copper world. But the final thing here is the electronics. And this is perhaps the most important thing on the slide. Now, while we spend a lot of time talking about cable, it's the electronics that actually make fiber usable. So for all those guys that would come to these classes, raise their hand and say, look, I've installed fiber for 20 years and we never used it. Why is this any different? Well, the thing is, the fiber that's been installed really up until the last couple of years, there wasn't anything to connect to it. So while we had a cable that was capable of all these great things, there were really no electronics that we could use with that fiber. And frankly, we didn't need to use electronics with fiber because Cat5 handled the bandwidth we needed to work with. That has changed. And it's the electronics, the little black boxes that make fiber deployable. So it's really interesting, often overlooked, very early on in the market, right? Electronics are usually one of the last things that go into the installation, but it is driving the mind share of the industry. So let's talk about why fiber. Why are we seeing this? Why are we talking about this? What's getting the attention of the industry right now? Well, we've seen this slide before, right? We're AV professionals, we're low voltage professionals. We've seen this evolution from standard definition up into 4K, right? We remember our Sony Trinitron TVs that weighed 400 pounds, that had a beautiful component video on them. Well, guess what? We're not doing that anymore. We've seen our technology evolve into 720p, 1080p, and today most of what we're doing is 4K. And 4K is an interesting thing because depending on the different components of that 4K signal, we are going to be either above 10 gig in bandwidth or below 10 gig in bandwidth. And 10 gig is the magic number. 10 gig is the max capacity of Cat5, Cat5e, Cat6, even things like Cat6a, F-class cable. They max out at 10 gig. Now, if we're dealing with 4K, 60 frames per second, enabling HDR, so what we would call in the industry 4K 60 444 HDR, we're above that 10 gig threshold. Okay, we're approaching 18 gig, and that's why a lot of manufacturers like me, you'll see on our electronics, we label them 18 gig 4K, 18G 4K, or maybe 10G 4K, right? We're denoting the chips inside the technology and how much bandwidth it can handle. Now, here's the thing, right? We're exceeding 10 gig, so we can't natively take those signals and we can't natively push them over twisted pair, but we can do that. We can take a 4K 60 444 signal and run it over twisted pair by compressing the color space. Now, it's not ideal, right? You got to compress the signal. There's going to be some artifacts and some, signal issues, processing issues because of that. Usually you see some color banding, maybe some artifacts, but it's possible. We can run these high bandwidth signals over twisted pair by compressing the signal. Now we got a problem, and that problem's 8K. Because while it is possible to take 18 gig, compress it down below 10 gig, it is not as feasible to take an 8K signal, which drives the bandwidth up to 48 gig, and compress that below 10 gig. It is a massive compression algorithm. And frankly, you destroy the integrity of your signal. 8K is a game changer for a lot of different reasons. Okay. One is because it does drive the need for fiber optic infrastructures. Fiber is the only way in today's, marketplace with today's technology to drive the bandwidth needed for 8K. But it's also a game changer because 8K is the first broadcast standard. And I like this. This is a really interesting thing here. 8K is the first broadcast standard that's not actually designed for broadcast. It's designed to be streamed. So now that we have our 8K displays, and we're seeing this, right? All the major display manufacturers, projector manufacturers, we're seeing the 8K model ship. They're available. Just like anything else, we're seeing pretty high prices, which can be a great thing for us integrators, right? We can make some money on displays again, but we know those prices are going to come down as we start to see momentum. But it's the content and the delivery mechanism that makes 8K so unique. It's a broadcast standard not designed for traditional broadcast. It's designed to be streamed, meaning that the folks who are watching their TV now through DirecTV Now, through Netflix, through YouTube, through, Charter Spectrum, all of these different broadcast providers and streaming providers, right? They've changed their business models. They are prepared for streaming content. That they're prepared for allowing these 8K streams to move around. And for us as the low voltage professional, it's a really interesting opportunity, because while we're talking about fiber to move our video signals, we also have to talk about fiber to handle our networks. And a network that is designed to stream 8K, 4K, even 1080p is going to have a lot of demand put on it, okay? This is where us as integrators, us as those professionals, we have to look at our infrastructures and say, okay, fiber is now coming to the home. We are seeing this across the United States, and frankly, across the world, we are seeing fiber optic networks being deployed. Okay, our job is really to connect the dots. I tell everybody, our job is to connect the dots. If you're getting fiber to the home, why wouldn't we put fiber in the home? You're going to need it for the bandwidth for video, for streaming your content, right? But you're also going to need the bandwidth for all the other devices that are in the average home. If we look at one of the CES statistics from actually a year ago, the average middle class home in 2018 had 23 connected devices. So what are those, right? It used to be our laptops, our phones, our tablets, but today it's our wearables, our watches, our security systems, our thermostats, our appliances. Everything is becoming web enabled. And while the streaming video has a big call on that network, we got a bunch of other devices which are also looking for traffic and creating traffic. So the fiber optic infrastructure in the home, in the commercial business, it has to go to a medium that's going to allow us to handle these larger bandwidths. So we're selling for video, we're selling for networking. It's a huge opportunity for us. And that's not the only advantage for fiber, okay? We're also seeing other reasons why fiber has been around for 20 years, right? When we talk about the security market, why do we like fiber for security? Well, we get long distances. We can take 4K 6444 video signals and run them up to 20 kilometers point to point with literally 0 frame rate latency. We do this every day in Las Vegas. Massive market for our technology because fiber handles the bandwidth. It moves these signals from point A to point B incredibly fast, almost at the speed of light. That's what we're dealing with, optics. But we also see advantages, again, security, these longer runs, because fiber is immune to lightning. It's immune to static electricity. It's immune to electromagnetic interference and RF interference. We get a higher integrity signal out of a fiber run. I'm from Chicago. One of the things that we see in these older cities, these bigger older cities, is we have crazy ground potentials in these older buildings. And when you have crazy ground potentials in older buildings, we know that can wreak havoc on our twisted pair infrastructures. We rely on the ground planes to make things work. Fiber doesn't care. Because we're not sending any electricity from point A to point B, we don't have issues with these different ground potentials, ground planes. Fiber doesn't act like twisted pair extenders. It doesn't work like HD-base-T. It's incredibly immune to the noise, the interference, and that's why we see this and have seen it for years being deployed in military and government and medical applications. So fiber is definitely the new medium on the market. It's certainly designed for the bandwidth that we require in AV infrastructures. It certainly provides a better, more reliable experience for our customers. Our customers understand it, right? The actual end users, thanks to all the telecom marketing, they get the value of fiber optics. But the biggest thing for us, for anybody who's new to fiber, is it's easy to handle. Again, you're terminating in less than a minute, and it's really affordable today. People are surprised. I mean, we're dealing with cables that are under 40 cents a foot, right? With two different strands of fiber in it. We're dealing with electronics that are in the $300 price range to move our high definition signals from point A to point B. So we've seen the prices really come down on all of these components over the last couple of years. And that's just because the volume has been increasing. This is becoming very common in installations. So let's look at fiber optic cable construction, okay? And now keep in mind, right, these are the CEDIA slides. This is when I go on site and teach classes, this is the agnostic deck that we tend to work with. So you will see variations between different manufacturers out there, but for the most part, we all have fiber optic cables. Those cables have a jacket on them, and that jacket material can be in plenum, it could be armored, it could be direct burial, water rated, right? You got a jacket on the outside of the cable. Now, inside that cable is where it starts to get interesting. The fiber, the strengthening fibers. This is the yarn. So if you've ever cut open a fiber cable, you'll see all this little yellow yarn inside of it. Most of us use Kevlar to make that yarn. And Kevlar gives these cables an incredible amount of strength. I mean, you'll look at a fiber cable that is half the diameter of a pencil, 3 millimeters, really small cables. This always gets people's attention when we're in a live training and I'm walking around with the cable. But you see this tiny cable with these little yarns inside. And then I tell you that this cable has a 220-pound pull rating because it's built with Kevlar. Fiber is actually stronger than just about any copper cable we've worked with in the AV industry. It's also far more pliable. It used to be the case that when you take your fiber and you'd handle it in the field, you had to be careful because if you bent it more than 30 millimeters, you'd break it. You break it, you're done. Now, what we see with these modern fiber cables is you can literally tie these things in knots and they don't break. So it's incredibly different experience today with the polymer technologies that keep the fiber from breaking, the Kevlar technologies that gives you your strength in the cable. It makes the experience much easier for integrators to work with this in the field. And then once we get past all of that, the polymer coatings and the strengthening fibers like the Kevlar, we get into the ultimate core. And the core in these cables is what's transmitting our light back and forth. But before we talk about the light propagation and the glass inside the cable, let's talk about some of the cable construction. So in the fiber world, when you're going to buy a cable, you're really buying it in one of four different formats. Simplex fiber, and here, let me take a step back. We don't talk about fiber in terms of conductors because we're not conducting anything. It's not like copper, right? We talk about fiber in terms of strand count. So if we start with the most basic, simplex fiber, that is one strand of fiber. And you can use one strand of fiber for a lot of electronics, AV electronics. We make extenders that, use one piece of fiber to transmit those signals, 1,000 feet. But I tell people, we almost never want to pull simplex fiber. Okay. And even if you can use simplex fiber for what you're trying to do, we don't pull it because you're not future proofing. When we look at high bandwidth technology and certainly network technology, bulk of fiber is used for networking. 99% of network technology requires two strands of fiber or duplex fiber. So it is best practice to, at a minimum, pull duplex fiber, two strands. That's going to future-proof your run. That's going to allow you to use it for AV, networking, control, whatever you want it to do. Duplex should be your standard at a minimum. Now, we also get into multi-strand fiber. Okay, and multi-strand fiber is where we have lots of different pieces of that little fiber inside an outer jacket. And it really comes in two different configurations. So breakout fiber is where those inner strands inside that outer jacket are pretty heavily jacketed themselves. It makes those inner strands more durable. They're beefy. They're robust. This is the cable that's really nice if you've got some security cameras at the top of a pole. You can run your breakup fiber up that pole and then unzip it and take each one of the strands and go to the different cameras or go to a media converter or something like that. Now, micro distribution fiber also has all those little strands inside, and you can get these cables in, 4 strand, 6 strand, 8 strand, 24 strand. So lots of different variables depending on how many pieces of fiber you need. But you got all those individual little pieces of fiber inside an outer jacket. And the strand counts get pretty high. You can have a 3 millimeter cable. So that's a tiny little cable with 12 strands of fiber in it. How do we manage that in the field? Well, here's the other part of all of this. Fiber optic cabling is designed to be used with fiber optic installation components, things like rack trays, things like wall boxes. And what you'll notice, depending on what manufacturer you get your equipment from, those rack trays, those wall boxes, those keystone wall plates, whatever it is, if it's designed for fiber, you'll see things like coilers inside. You will see things like breakout panels inside. So the fiber optic components are designed to take into account these little strands of fiber, need to be supported, need to be protected. And by the way, a lot of people, again, they buy pre-made fiber, right? Where you come to us and say, I'm doing a gate cam installation. I need 600 feet. I need 700 feet. I need 1,000 feet of fiber, and I need the connectors to be pre-terminated on there. Well, these rack trays, because fiber is so small, makes it very easy to coil up the slack and keep it inside, protected in the rack tray, in the wall box. Fiber optic technology is designed for that, and this is all part of that ecosystem that we work with. Now, when you start designing a system, there are 2 different types of fiber that you're going to run into. And the nice thing is, fiber is really color-coded. So unless you have something like an outdoor direct burial where there's an outer jacket on the cable, outer armoring or something like that, fiber is going to come in single mode or multi-mode. Single mode fiber is the yellow one. And this is a little bit counterintuitive, okay? So when we think about how copper systems work, we tend to think about distance. We tend to think about bandwidth. In single mode fiber, the yellow cable is the fiber we use for going longer distances. So the reason I say it's counterintuitive, when we think of how do I take a copper-based medium like twisted pair or speaker wire or control wire, if I want to send my signals longer distances, I put more copper into it. In the fiber world, it's the opposite. So single mode fiber, being the fiber that goes longer distances, actually has less glass. It's a smaller diameter. Multi-mode fiber, the aqua-colored cable, has a bigger diameter. It's a bigger piece of glass, and therefore it maxes out at about 1,000 feet. So if we look at why this is the case, it has to do with how light propagates. So a multi-mode cable, that aqua-colored cable, it has that bigger piece of glass. And as those signals, those little light waves are traveling through that piece of glass, right? They're bouncing back and forth. They're moving through the cable. They're going through the core inside that fiber. They start to get out of phase at about 1,000 feet. As they're bouncing, they get out of phase at about 1,000 feet. Now, single mode fiber, much smaller piece of glass. This is a 9 micron core versus the multi-mode, which is a 50 micron core. That 9 micron core keeps those signals in phase much longer distances. So when we look at the 2 types of cables, that multi-mode, the aqua-colored cable, that maxes out at about 1,000 feet, whereas the single mode fiber, the yellow one, most electronics, you're going 12 miles, 20 kilometers, point to point before you're reclocking your signals. So it's a very different way to work with the 2 different cable types. Now, here's what I'll tell you. All of us are going into installations where we will have existing fiber pulled. There is not one better type of fiber than the other. Both support a tremendous amount of bandwidth. We'll see that here in a minute. Both are easy to work with, right? Different sizes of glass, but that's about it. Our tools will work with either type of fiber. It really comes down to standardizing on one piece of glass, if possible, in your installation, because what you can't do is you can't take an aqua cable, the multi-mode, and splice it into a yellow cable, the single mode. You can't do it. They're different sizes of glass. Now, you can get a media converter, electronics, that will allow you to splice them together, but it costs money and it gets clunky. So when you get into projects, if at all possible, stick with one type of glass. Stick with one type of fiber, make it your standard on that project. I will tell you that most people, they use multi-mode, the aqua-colored fiber, because the electronics are less expensive, it's the easiest fiber to handle, and it tends to be a standard in the industry. All right, so now when you get into purchasing your fiber, you will see fiber comes in grades. There are ratings for it, okay? And if you're dealing with single mode, you will see an OS1 or an OS2 on the jacket. Now, the good news is OS1 and OS2 speak to the construction of the cable. Single mode's a really easy thing to work with because just about all the single mode fiber you're going to see in the field, you're going to work with, you're going to purchase, right? You're going to install. It's all OS2. Pretty standardized. It's multi-mode where we start to get into some gray area and it gets a little bit clunky. OM1 and OM2 are the older types of fiber. These are LED optimized, okay? OM1 is actually a different micron size, so it's incredibly hard to work with, and it tends to be incredibly brittle. You don't see much OM1 anymore. You still see a lot of OM2. And OM2 does support relatively decent bandwidth, but at very short distances. It's LED optimized. And the electronics today, they're laser based. Best practice, and what we really see in the field, is people are pulling OM3 and OM4. These are the standards. Now, OM5 is available. You tend to only see it in some of the military, the government, and the really high-end enterprise applications. But there's not a huge value. There's not a huge benefit of going from an OM3 or an OM4 to an OM5. So we just don't see it being installed. Now, I often get the question, are we truly future-proofing if we're pulling an OM3 or an OM4? And the answer is yes, okay? When we look at those fiber cables, OM3 and OM4 and OS2, so the single mode OS2, these cables support up to 100 petagigs worth of data. The glass inside these cables, 100 petagigs worth of data. That's 10,000 times more bandwidth than a Cat 6A cable. So the fiber cabling, you are future-proofing when you pull fiber. You are putting in a cable that can be used for all kinds of different applications that can support just virtually unlimited amounts of bandwidth. It's frankly the electronics which just are not catching up yet. The electronics continue to evolve. So if you're looking to future-proof, fiber is the way to go. You've got plenty of headroom as the electronics tend to evolve. Now, there's two different types of connectors that you will likely be interfacing with: LC connectors and SC connectors. There are more types of fiber connectors. There's ST, there's FC style that we run into from time to time, MPO, MTRJ. But in the AV world, in the networking world, it tends to be LC and SC. These are the standards. And the good news is these connectors all have the same physical performance. They have the same bandwidth characteristics. They move the signals from point A to point B. It's really the type and the style of the connector that you're dealing with. LC are the most popular. So if you have to err on the side of one connector versus the other, I always go with the LC. This is what's going on to most SFP modules, so the fiber modules that go into network switches. Most electronics manufacturers in the AV space, we use LC connectors because they're smaller. you can make your devices smaller. You can fit more of these connections, next to each other, point A to point B. If you learn how to terminate one type of connector, like the LC, for example, you can terminate the other types of connectors because the process is almost identical. It's just the length of the fiber that you're sliding into these connectors. And these connectors terminate in less than a minute. So it's very fast to terminate an LC connector or the bigger style connector, the SC connector, in the field. We see that you can work with these in the field. And again, it's really hard to, properly show this in these webinars, but I do encourage you to watch some of the videos online that'll show you just how easy termination is. They walk you through step by step. They're like 5-minute videos, and you'll actually see how this works. And here's the other good news. These connectors, they're reusable. So as you're learning, as you're working with them in the field, if you don't have a good connection, you can pop that connector off and pop it back on. You get about 12 tries to get it right. And trust me, I've never seen anyone who doesn't get it right within 12 tries. So it's really not that difficult to get into. Now, I mentioned before, it's the electronics that actually make the fiber deployable in the field. And what you're seeing now is these electronics, and there's a lot of different varieties, whether you're doing HDMI or USB, there's even some options for DisplayPort now. But what you'll notice is, one, the electronics are really tiny. The optical engines to send AV over fiber, they're small. I mean, you can make some pretty compact devices. But the other thing is, manufacturers like Techlogix, we have focused on making the fiber extenders look an awful lot like HD-based T extenders. And they act a lot like HD-based T extenders. You have ports for control. You have ports for ARC. You can actually use these black boxes with the fiber cabling to send your signals from point A to point B. And you can use them in an infrastructure capacity, so in a design that really emulates how you've been designing for years with twisted pair cables. Now, one of the things, so you will see these boxes, they start around $350 a set. So they cost more than an HD-based T extender. The prices come down quite a bit, but they still cost more than an HD-based T extender. However, they deliver the ability to send fully uncompressed signals from point A to point B. And so often in my travels, I'll see these high-end theaters that are going in where we've got a $15,000 projector, or hey, we're putting in the new, 8K TV, $15,000 to $70,000, depending on, which make and model you're purchasing. Why would you compress the signals that are moving from point A to point B? And what I tell everybody is, most consumers, when they understand the amount of money that they're spending on their peripherals, their displays, their projectors, they don't want compression on their signals, and that's what fiber optic electronics deliver. So before we wrap up here and maybe take some questions, let's talk about a couple of troubleshooting areas to make sure you're designing properly. We're going to look at the link budget. This is a very important concept. In fact, most companies that have been operating and working with fiber for, years don't fully understand the concept of a link budget. I will show you also how to verify your connectors terminated properly. What tools do we use to do that, right? Cleanliness of the installation might not be what you expect, especially for guys who are used to fiber. They're used to having to polish and clean the fiber. That's not what I'm talking about here. And then the bend radius. But let's start with the link budget. So the link budget, very important concept. You got to understand this if you're doing audiovisual installations. It really comprises of two different areas. One is a loss budget, okay? The loss budget, think of it this way. Anytime you're doing a cable run, you're installing cable and then the accessories that go with it, like, wall plates, rack trays, patch panels. We can look at those runs and we can do a quick calculation saying, I expect, based on how I'm running this cable and what I'm going through, what my signal's going through, that there's going to be some loss. The loss budget is the amount of anticipated loss on the cable run. The power budget is how much loss your devices can tolerate before they fall apart. So if we think about like extenders, HDMI extenders, they can tolerate loss, but not too much loss, because if it's too much loss, the signal falls apart. Network equipment, it can tolerate loss, not too much loss. If there's too much loss, we start to have our signals being affected. So if you put the amount of anticipated signal loss with the amount of acceptable signal loss based on the electronics in play, you get your link budget. So where does the power budget come from? And why is this such an important concept? Well, historically, companies that worked with fiber, they were mainly in the networking world. They're using networking equipment. And the power budget for most network equipment is 11 to 22 dB. That's a lot of loss, because think about a network installation. If you got loss on that cable run, bad connection or something like that, you don't lose your signal altogether. It just slows down. Poor network signal means slow down in quality. Still works, it just slows down. That's not how AV works. Those TVs, when we're trying to send an HDMI signal from point A to point B, if we have any signal loss, any dropout, we lose the signal. And then we got to reclock. That's what happens when you've got, a display that's flickering, that's constantly reclocking. That's a deal killer. Where a consumer can get away with some loss in a network installation because it's just simply slower, they will not tolerate their TV flickering on and off, their projector losing sync. Does not work. So the power budget for HDMI or AV over IP or DisplayPort, or frankly any video, that tends to be around 3 dB, much more sensitive than a networking application. And you have to make sure that you're installing the signal or the system properly to account for that. So where does the loss come from? Well, the connectors, there's some loss, splices, keystones and couplers, right? All of the different stuff in line and even the cable itself can create loss. But when you start to put it all together, it does take a lot of different connection splices in order for you to really get to those power budgets, get to that 3 dB of loss. So a typical installation that we run into day in and day out, we've got a rack. In that rack, we've got an HDMI extender. That HDMI extender is going to push the signals through a connector, bulk cable. Often you'll see like a wall plate in line, and out of that wall plate, maybe a patch cord going to the other end. In this installation, if we did a decent job, not even a phenomenal job, but a decent job terminating, connecting everything, we can calculate this out and say, hey, this run should have about 1.3 dB of loss. That's well within my budget of 3 dB. So this system should work just fine. It's when we actually install all of our cable and our equipment and then take our test kit, the little meters, right? And this is another part of what we do. We have meters that you plug into the two ends of that cable, and you realize that it's not at 1.3 dB. It's at 5 dB. It's at 7 dB of loss. We got a problem. And that's where meters are become a very important tool for you out in the field. You can actually calculate the amount of loss on your entire cable run. VFLs, this is part of any basic toolkit, termination kit. This shows you if you've got connectors that are terminated properly. Between these two tools, these are going to be your best friends. VFL's telling you if you terminated properly, and then the test kit will be telling you how much loss you have. Now, often, because we take a lot of tech calls here at Techlogix, often when somebody calls up and says, man, I think I did everything properly, right? I know my connectors are on there properly. I'm looking at my link budget here, and I don't have that many splices in line, but for some reason I got so much loss on this. What's going on? The majority of the time, it's because we have dirty connections. And if we think of those real world installations, well, we're not sitting in clean rooms, right? Our rack areas, our rack rooms, they're usually construction sites, and there's dust, the handling, oils from our skin. All of these things come together and they contaminate the optical lenses inside of our equipment. And this is why it's so incredibly important that when you receive fiber optic cables, fiber optic electronics, couplers, splices, whatever it may be, they all have dust caps in place. The dust cap keeps those optical lenses clean until you're ready to terminate, ready to connect things. Now, one of your other best friends is going to be what's known as a pen style or click cleaner. These are little, basically like pen devices that you just stick in those connectors, stick in the SFP ports, the fiber module ports, for electronics and, couplers and splices and things like that. You literally stick it in there and click it, and that cleans the optical lens. These cleaners, cost around $50-$60, but they will be your best friends because you will take a system that's got too much loss or on the borderline of too much loss. You will clean the connectors, you will clean the ends, and you will be well within your link budget. It's amazing. But think of it, you're moving light. You are moving lasers from point A to point B. You need to make sure that there's high integrity of those lasers being able to propagate through the cable, through the optical lenses, and into your electronics. So cleaning your devices, not necessarily the cable during installation. You don't have to clean the cable when you're terminating. It's not how modern fiber works, but it's the optical lenses in the ports, in the cable ends. That's what we're cleaning. Now, really, the final thing that I want to mention before we wrap up here and see if there's any questions is fiber bend radius. So I mentioned these modern polymer fibers, right? Most of what we're using in the AV industry, you tie this stuff in knots. The bend radius is 3 millimeters, which is about the size of the cable jacket, hence why you can tie it in knots. It's incredibly durable. However, most of the fiber that you're going to see and work with in the field is not SSF grade. It is not polymer clad and polymer based. It's traditional fiber. And as you're working with fiber that's been installed in the field, you want to make sure that you're handling it properly. And that fiber typically has a 30 millimeter bend radius. If you learn how to terminate, you can work with that fiber in the field. You can use mechanical connectors on it. The same connectors we sell can be used with our fiber or other traditional fiber. I call it traditional fiber. So the things that you're learning today and that you're going to learn as we go along and work with fiber, you can apply that to different manufacturers. And there's a lot of universal technologies here at play and a lot of standards that come into the fiber optic network, but it's the handling. You want to make sure you handle traditional fiber fairly delicately because it can break. And you're lucky if you break it and you know that you broke it, because what tends to happen with fiber is you'll get a crack in it and it will gradually degrade over time. It can be incredibly frustrating. So with all of that said, I am here for any questions that anyone may have.
All right, Cameron, can you hear me?
Yep, hear you just fine.
Nice. Okay. So, yeah, we've got a question here. So, this is a pretty common thing. So, we've got a question about 10.2 versus 18 gig versus 48 gig for 1.4 versus 2.0 versus 2.1. How that relates to the incoming ISP speeds, where they're 500 meg or gigabit or 2 gigabit. Yep. So the question is, hey, if a guy's only got like a 500 meg ISP connection or even a gigabit ISP connection, is he going to be able to get a stream of 48 gig to one TV and maybe like an 18 gig to a second TV off of an input that's a small fraction of that?
Sure, absolutely. Good question, and this is an incredibly common question that we get. And I'm going to do something here real quick. I'm going to flip over to the website because I can visually show you some of this here in a minute. So here you go. Here's the Techlogix website. And you'll notice, so, here you can go into products, you can click on like fiber infrastructure and see all the different fiber devices that are out there. But I encourage people to use the search engine because we do a lot of articles. And one of the most popular articles we have, if I type in DMARC wiring, and in these articles, and you can type in crazy stuff like RJ45 fiber, all kinds of different things. But the DMARC one, this is kind of the start of the answer to the question, and this shows you how to wire those DMARCs, whether you have copper in, fiber out, fiber in, fiber out, copper, whatever it may be. There's like 7 different ways to wire. But here's the punchline. There is a difference between packetization and compression. So if somebody's got a 500 meg line in or a 100 meg line into their home, that's not to say they can't watch 8K. You can, okay? That copper DMARC, that copper feed to the house will still allow you to stream high bandwidth. It's just going to limit how fast it is. What we're looking at with fiber in the home is once you get that signal to the modem, past the modem, now's where speed becomes really important because you will need, once that packetized signal gets to the modem, gets into the network equipment, you're going to need the speed to distribute it through the home. So if you've got folks who are watching, that stream on multiple TVs, it's going to have to be fiber. If you are going to have, for example, a lot of other network traffic moving, from different access points throughout the house, it's going to need to be fiber. You will be limited on how fast the signals can come into the house, but once they get there, you need the speed to deliver them. There is no bad application for putting fiber inside the home. Because what we are seeing is those DMARCs, the service, the ISP, the telecom service, throughout the United States, most of that's getting upgraded right now. And people are now getting the option to move over to fiber. And that's only going to increase the ability to move signals.
All right, thank you.
Yep.
All right, the next question, and this is more, I think, goes to your custom program. I know you didn't really go too deep into the custom program, really. We got a dealer who's asking about overhead fiber. We've got a customer that wants to connect 2 outdoor signs. Now, usually, like for coax, we've got something that has a traveler, and the traveler carries the weight. Is there something like that? Does something like that exist for fiber?
Yeah, absolutely. So you're seeing that with fiber. We build all of that kind of stuff custom. It's pretty crazy when you look at some of these cables. You definitely don't have the weight that's associated with traditional copper cables because fiber's, polymer or glass based. The armoring gets a little bit heavy, but still we're dealing with cables that are incredibly small and compact. And I think again, turning to the website, I think I can show you what some of that cabling looks like. But the answer is absolutely yes, you have those options.
All right. Perfect. Okay.
So I'm going to show you. Here you go.
Steve,
here's one of the most common.
Follow up with us, and we can pass this request along. And then what we can do is, once Cameron quotes this off to you, if you get a sign off, what we'll do is we'll build a custom SKU, and then we'll place that order to the custom SKU. It's the same way we do Lutron shades. It's the same way we do Middle Atlantic, like laser cut faceplates to customized items. So we've got a mechanism to do that. So if anyone wants any custom configuration through Cameron, we can do that. And then what we'll do, like I said, we'll just have it quoted, create a quote number, and then we'll create a sales order and a purchase order based on the quote numbers.
Yeah, and here's that cable that I mentioned. This is the most popular one that's going to get hung or buried outside. It's got your outdoor rated cable with an armoring and then another internal armoring, and this cable's really light.
Holy cow, that looks like that would survive the wars.
It was actually built for the government military application, so yes, that's what it was designed for.
All right, perfect. Okay. The next question, you talked about polishing. So are there different ways to polish the different types of connectors that someone is going to see in the field, or would it be better to just re-terminate fiber that we see in the field?
Yeah, so here's one of the cool things about the modern fibers. So any bulk fiber that you're buying from us or AllNet today, you don't have to polish it. That's kind of a arcane technology that's no longer prevalent in the market. You don't even have to clean the fiber now when you're terminating. All you have to do is cleave it. You run it through the cleaver to give it a nice clean break at the end. Now, fiber that's been installed for years, yes, you do need to potentially polish it. You do potentially need to clean it before you put the connectors on. What I will tell you is what most people use, and I'll show you the different products, couplers, adapters. So whether you're going with like wall plates, or there are all kinds of different couplers and adapters that will allow you to take an older type of fiber that's already terminated, even if it's got some of these crazy connectors on it because it's really old, and then modify it for new modern types of fiber. And what you'll find is these little couplers, these little adapters are very affordable. They're actually less expensive than most connectors that you will buy to put on that fiber.
Okay. Hey, here's something we learned on a webinar a couple weeks ago. We had our friends from AVP, AV Pro Edge,
Yeah.
and what they told us is that the AOC cable that they sell right now, um, the active fiber cable that has a hybrid, it's got the copper lines for the power and then the fiber. They're like, yeah,
Yep.
yeah, that's made out of clear line SSF strands. So if you happen to have a projector run with this cable, he's like, expect it just a touch longer than you need because at the end, let's say at the end of its lifespan, instead of it being just a dead cable or using it for a pull string or whatever, is you can lap the ends off it, terminate it with SSF terminations. He's like, it's actually SSF internal. So we were thinking that's a pretty cool thing. So I mean,
Oh
obviously, what we
yeah,
want to do is we want to have
absolutely.
fiber interconnects in there as well. But if you're absolutely strapped and you've been putting those in the field, that was kind of good news that it's a terminatable piece of fiber. It's not like like a closed loop system that you can't reuse in any way.
Yeah, absolutely. And and more of us manufacturers, we are using standard fiber because it is a universal. It allows us to
Nice.
do much more with it. So whether it's, AV Pro Connect, cables, when you start to look at, a lot of the different like pre-mades, for example, that's why guys like to pull pre-mades because you can use it for everything. But this is all universal fiber.
Okay, perfect. All right. Yeah. So I mean, obviously, probably the most prudent move today would be to put like the highest quality HDMI in that run that you can, and then pull something like this alongside of it. And then obviously the next move up from that would be to pull just a very large conduit, something that you could fit a head through if you have to pull a pre-terminated cable later. But we can certainly do it with just do pre-mates. And then you don't have to worry. Just all we have to change ultimately is the electronics at the end of each side.
Yeah, and that's why we see a lot of guys who pull pre-mades. Honestly, most fiber that's being pulled today is being pulled dark. It's being pulled for future application, future proofing those installations. Most consumers, like I said, get it. They know they need fiber in the wall, and if you're pulling fiber today, or I'm sorry, if you're pulling cable today, pull the fiber along with it. It's going to save money in the future, and make money on it. Here's the other thing: the most common fiber you're buying at about 39 cents a foot, and the average national price is $1.50 to $2 a foot. That's what the telecoms charge for it. You should charge that for it. You can make money on this.
All right. I need to redock because I don't know where my questions tab just skated off to. Oh, here it is. Okay. Are there different SFP ports for single mode and multi-mode? Oh, that's a good question.
So there are. And if we go back to the web, what you will see is when you are looking for SFP modules, and by the way, 95% of manufacturers in the industry all use the same firmware inside the SFP modules. The only time you really see deviation from that is where you get into the really, really high-end network switches, like 48 port switches for $200,000, from HP. Most of us are all using Cisco standard firmware. And when you see these SFP ports, you will see they are multi-mode or single mode. You will also spec them in 1 gig or 10 gig. And there are also 40 gig and 100 gig SFP modules, but they're just not going in the consumer technology that we're putting into most AV installations. The other thing that most people don't know exist are DAC cables, interconnect cables. These will save you a lot of money in an installation. Basically, this is a cable that's designed to stack switches that has the SFP ports built in. They are a fraction of the price of buying an SFP port for each one of the devices and then a pre-made fiber cable. So know that DAC cables exist. These will be your best friend on installations. And you can get them in pretty long lengths too.
Okay, perfect. Yeah, we keep some of them. We keep the copper one, which is really short only, and then obviously from that we go straight to fiber. So
Yep.
we keep some of these on hand, and then obviously we special order anything long, or we special order the adapters and then pull the preterm pieces between them. Okay. I think that's it for questions. If anyone else has any additional questions, please type them into the questions box quickly. Cameron, as always, we're right on time. We try to be efficient. We try to be efficient here at AllNet. Okay. Let me see. Overhead, SFP. Yeah, it looks like we got to all the questions. So, Cameron, so what's new and exciting? What can we look forward to as far as technology shift with 8K coming out?
Yeah, so the big thing that we're all waiting on in the industry is the chips. We're starting to see the chips going into the display manufacturers. That's how the HDMI chips always start. They go to the big brands like the Sonys and Samsungs of the world. And as soon as those chips trickle down into the other manufacturers, you're going to see the 8K extenders. The optical engines are actually ready for it. So we're already building extender technology that can support the bandwidth for 8K. We just need to drop that chip in there. So, these little guys right here, these are ready for it. Like I said, a lot of fibers getting pulled. It's being left dark. Folks are, preparing to upgrade because those displays today are doing upscaling. We're starting to see the 8K content hit now. The other big thing that you're seeing from companies like Techlogix, and frankly, there's other companies that are getting into fiber, turnkeying that installation. The different mounting solutions, the different patching solutions, making this easier and easier to work with in the field.
Perfect. Yeah, so we had Sony on recently. We got Samsung on next week. So that's one of the reasons why we wanted to slot you where we slotted you in the webinar series, is because 8K is here. It's not something for tomorrow. It's something for today as far as pre-wire is concerned. Like you said, when these chips come out, we're going to have electronics to throw in there as well. So we're looking forward to this transition. The displays look fantastic. Of course, all we have to show on them is the internal demo content right now, or maybe a thumb drive here or a NAS drive there. But the time for us to be distributing these signals is coming up on us very quickly.
Oh yeah. Yeah, and fiber handles that bandwidth. The last thing that I'll really mention is for folks who want to learn how to terminate, you can go into our knowledge base here and you'll see you've got a lot of videos online. One of those videos is the termination. It's a simple, little 5 to 7 minute video that'll walk you through the steps. So check that out. that is the logical next step after a training like this.
Perfect. Okay, we're close to being out of time, and we don't have any more questions in the chat box. So on behalf of AllNet, I'd like to thank everyone for taking the time to join us today. As I said, next week we've got Samsung on deck. So if you have interest in learning about the Samsung 8K TVs, the new lineup, look for a registration from me shortly. Cameron, I want to thank you for your time today. We had a good session, and we had some good engagement. We had some really good questions. So once again, thank you for your time in partnering with us in this webinar series.
Yeah, my pleasure.
Okay. All right. Thank you, everyone. We're going to go ahead and end the session now. You will get a follow-up email from us, and I'm going to go ahead and include that link that Cameron just mentioned on terminating fiber. I'm going to put the link right in the follow-up email. So thank you, everyone.